Hello everyone, thank you for joining our webinar. Today it's an introduction webinar to Diana. That's a webinar that we run a couple of times a year. So some of you might be familiar with the format of this webinar. The webinar will take approximately 45 minutes. It will consist of a presentation to give you a kind of overview on the capability of the Diana software, followed by a short live demo where we highlight some of the features of Diana. And today we will focus on one of the new output that we have for the distributed moment, which is based on the wood and armor method from the Eurocode 2. So I will show you on a simple case how you can use this method. And we will also basically do a kind of comparison between the numerical and analytical value. This is all described in one of our latest tutorials that I will use as a base for the live demo. During the presentation and the whole session, your microphone will remain muted. But you always have the possibility to type your questions. There is a question box in GoToWebinar, so you can type your question there. And from time to time, or at the end of the presentation, I will have a quick scan. And if there are questions that are relevant for the whole audience, I will try to answer them on the fly. Otherwise, I will get back to you later by email. This session will be recorded, and within a few days it will be available on our YouTube channel. So you will have the possibility to basically watch the recorded session afterwards. So having said that, let's start with the presentation, and let's talk about Diana. So Diana is a short form of displacement analyzer and is a general finite element program, which is dedicated to all type of civil engineering structure. And it can be a bridge or a dam or any type of structure and infrastructure. But it's also quite a large use in the geotechnical and petroleum engineering. Our aim is to provide a range of efficient engineering solutions to the daily or specific types of engineering problems that by increasing the accuracy of the final results, our clients could optimize the cost of their project. Our core values of our company are presented on these slides. I would say that based on the trusted relation we develop with our clients and partner, we try to mature dynamic and innovative ideas to deliver the state-of-the-art solutions and a quality service in a world-class product. So it's quite ambitious, but I would say that's our daily target here in our Delft office. We have also quite a large network of scientific experts, and we offer a global support network. Next to that, we have also a lot of publications. You can find them on our website. We have a larger library of Diana publication. And we have also regular webinars like this one, but also technical webinars given by some of our key users. And I strongly invite you to keep an eye on our website because over there you will find the information about the upcoming event. And good to mention that mid-May we will have a technical webinar given by one of our key users, Koen van der Vliet. And he will share his experience with Diana that he has been using for the assessment of bridges in the Netherlands. So please keep a look on our website for the latest information and do not hesitate to register to one of our events. On the next slide, we present a list of some of our valuable clients. We have clients in different countries all over the world from different organization types. So it goes from governmental organizations, academic, it can be university or research organization, but also from the private sectors, like consultancy companies or construction companies, from different fields. It can be oil and gas, energy, underground structure. So we appreciate their effort in trusting and using Diana in their project, whether it's on a daily usage or on a project base. But we really appreciate their involvement and their feedback as well, because it really helps us to bring the software to the higher standard of the market. With respect to Diana application, I quickly go through the different possibility. We start with geotechnical and tunneling. We have a very good integrated solution for all types of geotechnical and tunneling applications. So you can use the integrated environment of Diana for any types of tunneling and underground structures. For ground freezing, also called three-phase analysis, we have the tool for that. For real structure interaction, so if you have some sort of interaction between the underground and the surrounding soil or rock, you can model it with the concept of nonlinear interface behavior. For coupled groundwater flow stress analysis, we have also a solution, and many more, like embankment on soft soil and consideration or slope stability. Next to that, it's also good to mention that we have many wizards available in Diana, whether it's for modeling of piles, sheet piles, with including predefined library of parameters. So basically, you are already assisted and guided through the model via this wizard. Next to that, we have a very comprehensive solution associated to reinforced concrete and early age behavior of the concrete cracking. That's mainly when the model and the casted concrete go through the process of hydration. For any types of concrete box girder or composite structures, could be interaction of concrete with metal or combination of concrete with fibers. For dam structures, it's also very important because of the process of casting, curing, hydration, and impounding. We have also a good coverage for design check, including the reinforcement based on the Eurocode, mobile load and design load generator, and indeed the cross-section design check. You can use it in conjunction with your bridge applications or your general structural analysis application. We have different solutions in order to give you good estimation about nonlinear response of the model without entering into the nonlinear detail parameter input and setup iteration like sequential analysis. Temperature and stress coupling let you analyze how the concrete goes through aging. Cooling pipe is also another powerful feature that we offer in both 2D and 3D in order to control the hydration process. Crack initiation and propagation in concrete, one of the powerful features in Diana. We have more than 40 years experience in that. And also fire effect, how the fire could affect the durability of your structure. Among other applications, we can refer to masonry and historical constructions. In Diana, we offer different solutions at meso or macro levels. You can use Diana to model the interaction between the individual bricks and the mortar joints. So you can really move to a very detailed approach. For dams and dikes, Diana offers this solution. It covers all the aspects of construction for all types of dam structures. So you can consider fluid structure interaction, dynamic effect, and also induced damage to the structure. Fire analysis is another area that, based on its importance these days, has become one of the main topics for structural check. And honestly, we can say that Diana can be considered as one of the most reliable solutions for that. For earthquake analysis, you can use Diana for general dynamic or seismic. For oil and gas and nuclear structure, Diana is also very well known in this field. Based on the type of complexity, you can simulate 3D geomechanical depletion or borehole stability. For nuclear structure, you can analyze concrete containments or underground rate storage. So as you can see, I mean, the variety of application is quite wide. Let's now take a look at the Diana environment. So I would say that the environment look and feel very natural. It's a Windows-based program. So on top, you find a toolbar with some shortcuts to the main functions, so you can really custom it based on your wish. Then we have multiple windows. The position of these windows are really up to you, so you can move it from left to right, from top to bottom. The only one which stay really in the center is basically the working window. So on the left, you have the geometry and the mesh window, where basically you find all the information about your model at the geometry level and mesh level. You have the property window that gives you more in-depth information for some of the particular items. Then on the right, on this slide, you have the analysis window. So basically you tell Diana what kind of analysis you want to perform for your model. And the output window, where basically results are automatically loaded once your analysis is done. And basically you can select which output component you want to display. At the bottom, you find two windows, the message window, which basically give you a kind of logging of your analysis progress, or eventually warning and error message if something goes wrong. And you have the command console, which is basically a Python command, Python console, because the graphical user interface of Diana is fully scripted in Python. So every command that you do in the graphical user interface results in a Python command. So it's also quite a strong feature because it basically allow you to do a lot of automatization or parameterization. And finally, in the center, you have the working window. That's basically where the magic happens, I would say. So this is the window where basically you display your model in terms of geometry, associated properties, but also the mesh and also the result. So everything is done in one graphical user interface. You don't need to switch between different windows. Everything is done there. So with respect to the environment, we try to deliver the state-of-the-art solution with intuitive graphical user interface. It has various display options and advanced selection method. The modeling functions are based on Parasolid. We have automated and robust geometry checking and repairing tools, which is quite practical when you deal with a CAD file and you import them. In terms of meshing tool, we have a powerful and automated mesh engine, 2D and 3D, including hybrid mesher. We have automatic generation of embedded reinforcement, piles, and sheet pile walls and anchors. For load and boundary condition, we fully support any type of load and boundary condition, I would say. We define everything at the geometry level, but still we have some flexibility at the mesh level. But basically our philosophy is really to encourage end user to do everything at the geometry level. You can define function, and we have full compatibility with Microsoft Excel. And for the post-processing, we offer a complete solution to result interpretation. Our material model classification offers separate dialog boxes with various input fields. You have also some unique aspects that you can activate at the material model level. These tables are interactive, and you can use a function or variable dependency. For load combination, you can generate a design load combination and also a distinctive load combination for analysis. As I mentioned in the previous slide, you can generate function, whether it's a spatial or non-spatial function or a space function. The property window gives you some control on parameterizing the selected operation. And finally, the analysis window gives you an intuitive environment to set up any type of analysis, including the interactive face analysis. So for instance, here you can see that you have a screenshot with all the element set, and you can check which one should be activated in which phase. So this is very intuitive and natural. In terms of workflow, let me take some time to go through this slide, because this is an important one, because the story that I'm going to tell you now apply to any model. So the workflow in Diana is as follows. You define your geometry. So all the components of your model, you define the geometry. On this geometry, you assign your properties. By that, we mean you define the material, the boundary conditions, the load, eventually the initial conditions. You assign everything at the geometry level. Once all the properties have been assigned to your geometry, then you generate the mesh. Then your finite element model is basically there. And then you set up the analysis and tell Diana what to do with this finite element model, what kind of analysis and what kind of output you want to see. You run the analysis. Automatically at the end of the analysis, if the analysis has been performed without any issue, automatically the results are loaded to the graphical user interface, and then you can check your results. So it means that for any change you may want to, I don't know, for instance, you want to change the Young's modulus of one of your material, or you want to change the boundary condition, you do that at the geometry level. So it means that before this change is transferred to your finite element model, you need to remesh. But don't worry, I mean, Diana will let you know that. But the main information here is everything is done at the geometry level. So you define all the components, all the properties, all the assignment, and then you generate your mesh, and then you run your analysis. And this workflow will apply to any model. Doesn't matter how complex or complicated is your model. This strategy will apply to all of them. Regarding the modeling, we have many options to create the geometry of your model. We can start by importing your geometry from a third-party CAD program, or you can generate the model from an integrated environment. It's up to you, but if you are dealing with CAD program, you can basically import it to Diana. Diana can handle DWG, DXF, STEP, and IGS file. You can also import file for IFC file format if you are using Revit. Furthermore, if you are dealing with terrain geometry, for instance, you can import a cloud of nodes and generate what we call a Bezier surface in Diana from this node of cloud. This is also a powerful feature. And then after importing the geometry, there is a geometry check. Because if you are familiar with Diana or any other finite element package, you know that importing a geometry from a CAD file is not always straightforward. So you may need to check the tolerance and quality of the imported shapes, and you may also need to fix it, improve it, based on some warning or errors that can be raised. So for that, we have basically a certain number of features to enhance your imported geometry in Diana, such as the body check that allows you to find some of these issues, such as a short edge, liver face, small faces, whatsoever. But we have also tools basically to fix this issue after importing the geometry in Diana. One of the main advice we can give you is always when you work with your CAD model, try to make the CAD model as good as possible. So make sure that everything is connected, because at a later stage when you import it to a finite element package, then because of some tolerance issue and so on, you can have some loose part in your model, and it may require some extra work to fix the geometry before you are able to set up your finite element model. Otherwise, you can use the basic tools we offer in terms of modeling primitive to create and generate your model. For 3D, we have all the standard shape, from block to cylinder to prism to sphere. We have also 2D and 1D primitive, such as a polygon sheet, a line, polyline, or point. So all these are standard entities in Diana. We have also advanced functions, so you can sweep a geometry along a wire, for instance. On this slide, you have an example. We have a reference shape in 2D. We have a curved grid wire, and basically by selecting the shape and the grid wire, we basically end up with a nice 3D curved bridge deck. So in just 2 clicks, basically, you can create such an advanced geometry. We have also the lofting operation. I would say with a minimum information using this smart function, you can create advanced shape. Our selection window is interactive and object-oriented, so you can directly select them based on the selection filter. And as you can see on the right side, I mean, we have many items in the selection filter. So based on the choice, you are only able to select one of this sort of item. It's quite practical when you are dealing with complex model, because sometimes the selection might be a little bit difficult because of the complexity of the model. So for instance, if you want to select a specific face and you put the shape filter to face, then you are sure that you are not going to select the surrounding edges or points. We are using auto clash detection, so you don't have to worry about the nodal connectivity of the different components of your geometry interacting with each other. Diana automatically take care of that for you, ensuring perfect continuity and connectivity. So no worries on that side. We have other options in order to improve your geometry. So you can sew 2 or more sheets. You can convert body and sheets. So from a body, you can extract a sheet. From a sheet, you can make a body. So it works in both directions. For any operation in the model with respect to the loads and boundary condition, you can use the imprint options to have the trace and track of the imposed load, or boundary condition acting on your reference geometry. So this is also a nice feature. Other modeling operations enable you to rotate or move face or adjust your shape. This can be done via action box or directly with the mouse by dragging one of the 3 arrows showing the main direction, or rotating through one of the 3 circles representing the 3 main rotation. You can select and extract edges, faces, and then extrude them. So for instance, in this case here, we have a shape for which we extract a shape, and then we extrude it. And we can do that also via action box or interactively directly in the working environment. You can match different parts of your model with respect to each other using the align faces function when you have different objects in your working environment, and this can be done based on different alignment type. With respect to the functions, it can be assigned to the geometry to simulate the geometry thickness, for instance. On this slide, we have an example of a shell model, so a bridge, which is modeled with shells. And the special functions represent the thickness and eccentricity of the element. So it's also a nice way of modeling, and also an application of the special functions. But you can also use it to define phreatic water level, both in 2D and 3D. So this is a powerful feature for instance, if you are dealing with geotech application and dewatering, for instance. Another strong feature in Diana is the Python scripting, as I mentioned in introduction. And the geometry optimization with respect to the effectiveness of the model when it's subjected to such a load, and how you can reinforce and retrofit the model because of the load distribution pattern in the model. There are many powerful features that you can induce and use in conjunction with other tools that we have in Diana based on the Python scripting. So I would say Python scripting can be seen as first end as just as a echo of the command of graphical user interface, but it's much more than that. It's much more than that, and I would say if you want to get acquainted to the usage of the Python scripting, I invite you to have a look on our website. Early June, end of May, early June, we have our online courses, and one of the course modules is dealing with the Python capability of Diana. So if you are interested, I invite you to register to this course module. For meshing, we have different types of mesher. These are smart processes. They recognize the generation of your geometry. If your geometry is based on extrusion, then the extrusion mesh comes into the picture and generate a nicely patterned structure mesh. Here we have an example where we started from basically a 2D shape, but we extruded in the third direction. And when meshing, automatically the extrusion mesh come into the picture, and basically you end up with a nice and regular mesh. We have adaptive element size that enables you to increase the density of nodes and elements at certain corners and edges in order to have a smooth transition mesh. For instance, you have this example here where, based on the same mesh seedings and element size, you can see the impact of this option. And this option is this one. So if you check in the option, you can see that you get a coarse mesh in some of the corner where the density is needed. Without these options, for the same mesh shading, you can see how coarse is the mesh. On the next slide, I have another example. So if you have a terrain geometry, for instance, you can see the difference with or without the adaptive element size options. You can observe that in that case, without, you have something very coarse, which is not able to really capture the complexity of the shape. Where with this option on, you can have a smooth transition in some particular area of your mesh. So this is also quite a powerful option. You can also use grading to optimize your mesh. You have absolutely full control on the distribution of the nodes and elements. You can do that at the edge level, face level. So you can have some grading. So you have really a total control on your mesh. After meshing, you can visualize the type of sections that you have assigned to the model based on the different profile that we have in our library. This is done using the real dimensions, and it enables you to check the orientation and eccentricity. So this is quite a nice feature, especially if you are dealing with plate and beam model. You all know that basically your model looks like lines and plane. But having this real 3D cross-section visualization make your model more live and more realistic. So I really encourage you to use it if you are dealing with beam and the shell model. At the mesh level, we have different way of presenting that enables you to inspect or present your model in the most suitable way. It goes from wireframe to free-face edge. We have also some different solid shading view and shrunken shading. Also, there are different mesh engines which enables to generate structured or unstructured types of mesh sets. Here are some examples based on AutoMesh or MapMesher. So you can see that it can lead to very nice mesh despite the fact that they are complex structure. Another powerful feature is incremental meshing. This is very interesting when you are dealing with complex models and you need to do some modification at the geometry level. Can be for any reason. Thanks to this incremental meshing, you don't need to remesh the whole model. Dianama automatically goes for the meshing of the geometry parts of your model that have been subjected to the modification. This way you can save a lot of times in terms of meshing or remeshing of your model when subjected to change. So the change can be at the material level or at the boundary condition level, load level, or what else. Dyna will only remesh the parts that are affected by this change. At the end, we have a series of online documentation. It's an interactive documentation. You can find it on our website. We have also some verification report. We have a theory manual, and we have also more than 100 tutorials available on our website. And we have also many videos on our YouTube channel. So there is definitely enough material if you want to start or increase your knowledge of Diana. So this is it for my presentation. Let me quickly check if there are any questions. So someone is asking about information about the coming training on Python for Diana. I will show you at the end of this presentation. I will get back to our website and show you where to find the information about our courses. So let's now move to the live demo. And for this live demo, I'm going to use one of our latest tutorial that you can actually find on our website. let me quickly tell you what we are going to discuss. So today's purpose of the live demo is to highlight this new output for bending moment, which is based on the wood and armor method. And basically to do that, we will use a simple model, which is a concrete slab with a reinforcement grid under imposed deformation load. In this tutorial, we compare the numerical results with the analytical value obtained from the wood and armor formula. So you can find the formula in this PDF, but you can download on our website. So I will quickly go through the different steps. So first we will define the model, which is very simple. It's a slab. We will define the green reinforcement. We will assign a material model. We will define the reinforcement grid. Then we will define some support under conditions. We will apply self-weight, and then we will impose a deformation. And if you are familiar with Diana, you know that before to impose a deformation, you need to constrain the direction of this deformation. So we will basically do that on the fourth side of our model. So it will result on the following load. So basically we pull the side of the model. Then we will mesh it, and we will perform a linear static analysis where we will ask for the local distributed moment that are used basically to compute the wood and armor distributed moment. And we will look at the results of the wood and armor for the lower and upper part. And based on the analytical formula that we have, we will basically look if Diana give a good agreement. So having said that, let's start and move to Diana. So this is the latest version, Diana 10.8. So as I mentioned in my slide, I mean, any window can be moved from one direction to the other, on one side to the other. So it's really up to you to decide how you want to have it. You can hide some of the window. As you can see, I don't have many short cut here for the main functionality. I try to keep things relatively clean for the demo, but you can really customize the graphical user interface based on your need. So to start with, we need to define a new project. So we click here, and I call it demo wood armor. I have created a working directory where I'm going to save my files. So basically you can set the path to this directory here. And then you are asked about the analysis type. This is already an important choice, because this choice will impact the functions that or the type of elements, for instance, and boundary conditions that are available afterwards. By default, the structural is on, and we want to perform structural analysis, so that's perfect. The dimension of a model, we go for a 3D model. Here you are asked about the model size. That's basically the dimension of the molding box, or let's say your working window. I'm going to set up a 10 meter. It's big enough. And for the type of measure, I go for hexaquad dominant with a linear mesh order. I click OK, and automatically Diana is going to set up the environment for me. Here we are. In terms of units, you can find them at the bottom right corner, and you can change them based on your need. It's interactive, and automatically the rest of the program will adapt to the unit system. So for this model, we go for meter, kilogram, Newton, second, Kelvin, and radian. And the first thing we are going to do, we are going to define our slab, which is basically a kind of rectangular sheet of 1 by 1 meter. So I go to geometry, create, polygon sheet, I call it slab. It's a rectangle, starting position 0, 0, and the side will be 1 by 1 meter and in the XY plane. You see it in blue, but if you notice on the left side, under shape, there's still 0 shape. This is very important. I mean, until and unless you click create, no shape is created. So what you see is a preview, but nothing has been created yet until I click on create. And then you see that my slab shape appear there. So keep that in mind when you fill in the action box. there is always a create or apply button, so don't forget to click on it after any operation. So this is my slab. I'm going to make also a plane for the reinforcement grid. So one of the possibilities, for instance, is to select the plane and duplicate it. And then I call it, how I'm going to call it, reinforcement grid, for instance, Rinfo. I rename it, rename Rinfo grid. So basically now I have two shapes, the slab, one for my slab and one for my reinforcement grid. So I would say my model is almost ready. From now, in terms of geometry, everything is there. I just need to start the property assignment. So I'm going to start by assigning some property to my slab. So I select the slab. I'm going to use a regular curve shell element. And for the material, I'm going to use one of the material from the model code. So I'm going to use the FIB model code 2010. I select this one, no specific aspect to include. And here you see that all the properties are automatically loaded, and I go for the class C30, so I have nothing to change. My material model is there and good to go. And for the rest, I need to define a thickness of this slab. So I'm going to call it slab thickness, slab thick, for instance. And for this one, we are going to put it at, define it at 0.1 meter. And that's it. Everything is there. I can apply it to my shape. And now I see, if I pass the mouse on this slab, that there is a material, concrete, and an element geometry slab thick associated to this slab. And if I move to material, I see that I have a concrete material available. Another way to check the assignment is to basically color the shape by material color. So if I do that, you see that my slab turned to gray because it has the material concrete associated to that. So we have defined or assigned property to our concrete slab. Let's now define some property for the reinforcement. So I go to geometry, assign, I go to reinforcement property. Let me extend it a little bit. I'm going to hide my slab so that I don't only have my reinforcement grid. So I'm going to call it reinforcement. It will be a grid. I'm going to assign a material that I call reinforcement, not very original. No specific aspect to include. I keep it linear. And I put a Young's modulus of 1.611. Then what else do we need to enter? We need to specify some diameter and spacing. So for the geometry, call it grid. Let's call it grid. I go for the diameter and spacing, and over there I specify basically the distribution of my grid. So basically you have to imagine that you have bar in an X and Y plane, and you basically give a kind of distribution in this plane. So I enter the value for this and the spacing, 0.1, so this is okay. I have defined my material, my Young modulus, my spacing, so it's all good. I click on create. So automatically on the left side, you see that there is a reinforcement set created. It has zero shape. And what I can do is I select my reinforcement grid and move it to this set, and automatically it transforms the shape and associate the property of this set. So now I have my concrete slab, and I have my reinforcement grid. If I go to material, you see that I have also a material reinforcement for my steel. So everything is there. So what else do we need to do? I would say now we are going to define the boundary condition and then the load, and finally we will basically create the mesh. So basically create the finite element model. In terms of boundary condition, we are going to support all the edges of the slab with the following restrictions. So we are going to fix the translation in Z, so the out of plane translation, and we will also fix all the rotation x around x and y and z for the 4 edges. So I go to geometry, assign support, and I create support all edges. It will be part of a set, but I call support. It will be based on edge, and I select the 4 edges. I constrain the Z direction for the translation and the 3 rotation, and then I click create. What we can already do is create the constraint for the deformation. As I mentioned, we are going to basically apply the prescribed deformation on all the edges, on the 4 edges, in plane and perpendicular to these edges. So it means that we need for every edges to constrain the direction where we are going to apply the constraint. So we can already do that. I'm going to call it, for instance, support 1, yeah. And it will be support imposed depth. So I'm going to put the model in XYZ plane, and I'll start with this one. So in this one, I'm going to constrain the X direction. I click create. I'm going to do the same thing for the support 2, which will be this edge. I constrain the X as well. And then for this one, take the bottom, for instance, I'm going to constrain Y. And for the top also. So I have my 4 basically support condition that I will use later when I impose my deformation. You can find them under the support over there. So next, I'm going to define my load. In terms of boundary condition, I think everything is there. So I start first by defining my global load. So assign self-weight. Without typo, preferably. I click create. If I go to loads, you can find under cases my self-weight. And now I'm going to define the 4 deformations load. So basically 1 on each edge to apply the imposed deformation. So I'm going to start with the first one. So I go to geometry, loads, assign, loads, not the global one, the other one was too fast. This one. So I call it deformation load 1, for instance, deform load 1. It will be part of load. It will be a prescribed deformation, and I start with the first edge here. It will be a translation degrees of freedom, and I'm going to select my support, which is a constraint on this side. And the prescribed deformation, I'm going to apply minus 0.001 meter in the X direction. So basically, I will be pulling out my side on the left. I click create. I'm going to make the same story for the other side. So I select this one, and now my support condition should be 2. I click create. So you see in green the arrow appearing. Sorry, I made a mistake here. It should be positive. So I remove it. I do it again. So deform load 2, support 2, but here it should be positive because I want to pull the right side to the right. So I click create, and now you can see that if I hide the support, we can probably see better. You can see now the direction of the arrow. Now let's do that for the bottom and for the top. So select the bottom one. My support condition is 3, and here it's going to be minus because I want to pull it down, and it will be along the y-axis. And finally, the top one, it will be support condition 4. It will be positive because now I want to pull it up, and I create. And we are good. Now we have all our loads prescribed deformation applied on all the surrounding edge of our shape. So the model is ready. We have defined and assigned properties, loads, and boundary condition. So we can mesh. So I go to geometry, mesh properties, and here I'm going to select the shape. I select my not this one, but my slab. I'm going to use an element size. And for this model, I'm going to specify the element size of 0.05. And if you remember at the start of the project, I said, please use, if possible, hexa or quad dominant mesh. So it means that Diana will try to model this, model with a quad element with an edge of 0.05. Let's apply it and let's mesh it. And here is my mesh. So it's quite regular. The shape is really standard, so nothing complex here. So the model is ready. We have defined and assigned everything at the geometry level. Then we mesh. So it means that all the information has been transferred to at the mesh level. So if I go to the mesh tab, I can find all the information about my model regarding the reinforcement, regarding the elements, regarding the material, the geometry, even about the element types. I can put the support, I can put the loads. So everything is there. Now I simply need to tell Diana what I want to do with this model. So I'm going to add an analysis. And for this analysis, I'm going to use a structural linear static analysis. And here's the only thing I need to do for the purpose of our live demo is basically to ask for this output, the wood and armor distributed moment. So I go to the output of the linear analysis. I go to the edit property. If I leave it as it is, it will basically give me the primaries. So basically displacement, stress, strain, and reaction forces. But for today's demo, I want to make my own selection, and I'm particularly interested in the moment. So I go for the stress total distributed moment. So these are the local moment, which will be used to derive this wood and armor distributed moment. So I can also ask for the wood and armor distributed moment. But now I go here and add the lower and upper one. I just close, and that's it. I can run my analysis and look at the results. Just to avoid any freezing on my screen, I have already run the analysis. So let me bring it. Here is the analysis. So it's the same model. You see, nothing has changed. You have the different material. Everything is the same. The different constraint, all the components are the same. So automatically, once the analysis finishes, the results are loaded in your result environment, and we can basically start looking at the results. So first, we can present the result of the distributed moment in the local direction, so the MXX, MYY, and MXY, which from which the wood and armor distributed moment are calculated later. So we start with the MXX, so we can see the distribution. This is MYY, and this is MXY. So now we can present the wood and armor distributed moment for the lower. So maybe good to mention that there are two types of design distributed moment calculated. The lower ones, so based on the wood and armor method, the lower ones is positive, and it's causing mainly tension in the bottom part of your structure. And you have the upper one, negative, causing tension in the upper part. So, and these two are computed by combining the bending moment in the local X and local Y with the twisting moment XY, basically. So the wood and armor are basically a function of this three component. So having said that, let's get back to our result display, and I start with the lower part of the wooden armor. So we have the XX and YY, so I start with the XX. So here is the results. So 0 is basically blue, and you have the YY. And we can also look at the upper part. Also for the XX component, red is 0, the rest is negative. And for the YY. If I get back to my PDF, we have the formula of this wood and armor. And you can see for this distributed moment, so for the lower part, they are derived from a combination of MX and MXY and MY and MXY for the two components. And if the MXD is lower than 0, basically the following apply. And if the MYD is lower than 0, the following apply. And the same basically apply for the upper part. We have the same formula. I invite you to dive into the formula by downloading the PDF of our tutorial. But because of the limitation in time, I'm not going to dive into that. But the formula is there, so basically you can make the own calculation. We did that for you, basically, in this tutorial. And we have collected the results, or the Diana result for MXX, MXY, and MYY for two elements. We have selected two elements. You can select the same in a model. So for each element, you get 4 values, one per node. And basically, from this, we have computed manually the formula using the formula that I have shown in the PDF, the MXD and MYD from the wooden armor. And we have compared that with basically the output given by our wooden armor output. And we can see that our results are basically in a very good agreement, meaning that we didn't do anything wrong when implementing our wooden armor output. So it's always good to check that. So as you can see, this output is very easy to access. You just need to specify it in the output selection of your analysis. And if you want to practice, I invite you to use the tutorial that I used today for this live demo. And this is it for today, I would say. As you can see, it was quite simple. On such a simple model, we can already observe quite some interesting feature. So before we end this session, let me just quickly go back to the first questions, which was about our courses. So let me go to our website. Here is our website. if you go to the software service and go to training and webinar, you will find all our course activity. You will see that our next event is a technical webinar. It's free of charge and you can register. It will be given by one of our key users, Koen van der Vliet, and it will discuss basically the usage of Diana in the nonlinear assessment of 50s bridge. So it's quite an interesting topic. I invite you to register. And if you go a little bit down, you will see that we have an online course which is planned from May 27 to June 7. It consists in 6 modules, and one of these course modules focus in particular on the Python scripting and automatization in Diana. So basically, we try to give you some insight about the usage of Python in combination with Diana. So you can register for the 6 modules, but you can also register for each course module individually. You have all the information available on our website. Don't wait for too long because the number of seats is limited, and I would say that we have already a good number of registrants. But there are still some places available, so don't miss it. Don't miss it. Let me see if there are any further questions. There is a question: is it possible to display ISO value curve in addition to of the color for the result? Yeah, it is possible. I mean, you can play with the settings by clicking on the settings button here, and under the result menu, basically you can find all the settings, and you can see that we have one to plot basically ISO surface level, and you can you can play with that. You can have different level options. I mean, so all the options about tuning the results in terms of presentation and observation, you can find them by clicking on this icon, and it gives you this menu. And for result in particular, you can click on result, expand it, and here you have all the settings. And there are a lot. There's a lot. You can really you can really do a lot. Is there anything else? Yeah, the Wood and Hammer method compute distributed moment, and as it is mentioned on the PDF that I think I have closed accidentally, so let me reopen it. You have the reference of the Eurocode. Let me bring it here. So basically, the distributed moment, according to the Wood and Hammer method, are coming from the supplement of the Eurocode 2, and here you have the reference. So yeah, if you want to find more information in the Eurocode, you can refer to this section. So I think I have answered most of the question. As I mentioned in introduction, this webinar is recorded, and within a few days it will be available on our YouTube channel. And as I already said, keep an eye on our website. There are more events coming, so don't hesitate to register to our newsletter to be informed. And yeah, we will be in touch sooner or later through a webinar or online courses or anything else. But keep an eye and stay tuned. We are quite active. Thank you very much for attending this webinar. I wish you a pleasant end of the morning or pleasant end of the afternoon, depending where you are. And for the rest, yeah, let's catch up in one of our upcoming events. Thank you all. Bye.